Here we have a power series, and we want to find what's called the interval convergence. The difference between a power series and a regular infinite series is that the power series has an x in it. So the regular infinite series just has n, but the power series has both the x and the n. And so what we mean by finding the interval convergence is what we want to find is all x for which this power series converges, meaning what can we put in the place of x that would make this power series, that make this infinite series converges. For example, if we put a 1 here, if we let x be 1, would this series converge? If we let x be 2, be 3, be 4. And so we want to find all x for which this power series converge. And then all of those x values together is what's called the interval of convergence. And so to find all values, to find all x for which this power series converges, or find what's called the interval convergence, and then we will use the ratio test to help us to do that. And so first, let u sub n be this. And then we need to form, instead of a sub n, then we have u sub n, since we have an x right here. And next we need u sub n plus 1. And so u sub n plus 1, wherever we replace n with n plus 1. So replace that n with n plus 1, and then this n right here, replace it with n plus 1. So this becomes x to the n plus 1, and in the bottom we have 2n plus 2 plus 8, so that makes it 2n plus 10. And recall that the ratio test says that for regular infinite series, if we can show that the limit of a sub n plus 1 dividing by a sub n is equal to a real number less than 1, then the series converges absolutely. And so now we'll do the same thing. We'll find the limit so we need to find the limit of u sub n plus 1 dividing by u sub n, and then set it to be less than 1, because that's when the series converges. Recall that if it's greater than 1, the series diverges, or if it's equal to 1, then we have to use another test. And so to find the interval of convergence, or find the set of x values for which this this infinite series converges, then we have to set the limit of u sub n divided by n plus 1, u sub n plus 1 divided by u sub n. We set it to be less than or equal to 1. And so now this becomes this. So in the place of u sub n plus 1, we have that, and then in the place of u sub n, we have this. And then now let's simplify this. X to the n plus 1, that's the same as x to the n times x to the first. And then this becomes and then times. Recall that dividing by this is the same thing as multiplying by the reciprocal. So the reciprocal of that is 2n plus 8, and then dividing by x to the n. And we can see that this x to the n right here will drop out, and so what's left is the 2n plus 8, 2n plus 10, and then multiplying by x. So the x to the n will drop out. And then let's arrange the terms like this. And then we can rewrite this as this. Limit of a product is just product of limits. And then to find the limit of this quotient right here, we can divide the top and the bottom by n. So divide the top here by n, and then divide the bottom here by n. And then simplify. 2n divided by n is 2. 8 divided by n, that's just 8 over n. And then 2n divided by n is 2. And then 10 divided by n. As n approaches infinity, we get 2 plus 0, 2 plus 0. And so 2 divided by 2 is 1, and then times. The limit here is with respect to n, and so there's no n here. And so we can think of this absolute value as the constant, because the limit is with respect to n, but there's no n here. And so the limit of this part is just the absolute value. And so the limit of the ratio u, so we have this is equal 1 times the absolute value, which is the absolute value of x. Now, if we're using the ratio test, remember that the ratio test for regular infinite series, the series a sub n converges if the limit of a sub n plus 1 dividing by a sub n is less than 1. And so we want this, to know for this power series right here, which x will make this power series converges. And so to find that, we will set this to be less than 1. Because we know that if we set it to be less than 1, and then that will give us the x value. That will help us find all x that will make the power series converges. And so now we have this, but this right here means, remember that the absolute value of x less than 1, it means the negative 1 is less than x, less than 1. So that's what absolute value of x is absolute value of x less than 1 is equivalent to negative 1, equivalent to x between negative 1 and 1. And so this is what the radius. So from here we know that the power series x to the n dividing by 2n, it will converge for any x between negative 1 and 1. And then to get the interval convergence, we also need to check the endpoints. We also need to check negative 1 and 1. So when x is negative 1, then in the place of x, we put negative 1. And this if x is negative 1, then this becomes an alternating series. And if we go through the work, we will see that this alternating series converges. And then we also need to check 1. When x is 1, then in the place of x, if we put 1 to the n, it's just 1. So the power series x to the n, and then we have 2n plus 8, dividing by 2n plus 8, and now we let x be 1, then we get 1 to the n, which is just 1. And then we can verify by the integral test that this series right here diverges. And therefore, the interval convergence will be everything between negative 1 and 1, including negative 1, but not 1. And so what that means is this: if we let x be any number between negative 1 and 1, including negative 1, then the power series here converges. And the power series diverges for any x outside of this interval.